Okay, in the previous lesson we talked about relations, which was any set of ordered pairs, and then functions, which were special relations in which the x numbers never repeated themselves. Functions can be represented by ordered pairs or the mapping diagram that we saw, or a table or a graph, but functions can also be represented by an equation, or sometimes called a rule. Any equation that's a function will generate an ordered pair by taking an input number, putting it into the equation, and that will give you a certain output number. The graph of an equation is the set of all of its ordered pairs. So when you plot them on the graph, you connect them and it's going to form a line or a curve. Okay? So think of a function like a machine that takes an x value, you put something in, and it processes through the machine, which is the equation, and it shoots out a y value or an output number. The x value is called the input number, but it's also called the independent variable because it's independent of anything. You get to pick the independent variable or the input. You can pick whatever number you want to put into an equation. And when you put that number in, that's going to generate a y value. And the number that it generates obviously depends on what you put in. So the y value is always the dependent variable or the output. Okay, so let's look at how we graph some functions. You guys probably remember it's either called a function table or an input-output table, an x and y table. So here's my equation or my rule, y equals x plus 4. So if my input number is -5, I'm going to go back to my rule and I'm going to substitute in -5 for x. Now these numbers here, you get to pick them. You can pick any number you want. Sometimes it just doesn't matter what you pick. Sometimes it does matter based on the function or the rule you got. We'll look at one of those here in just a second. But in this table, -5 was chosen to be put in for x. So this becomes y equals -5 plus 4, plugging the -5 in for x. And then when you simplify this, that's going to give you your y value. So when you input a -5, -5 plus 4 is -1, you get an output of -1. When you input a -4 in here, -4 plus 4 is 0. When you input a -2 in for x, we're putting these numbers in for x every time, so you're starting over every time. So we put the -5 in, we got this out, then we start it over. Put the -4 in, got a 0 out, we're going to start over. Put a -2 in, -2 plus 4 is 2. Start over, put a 0 in. 0 plus 4 is 4, and now we can graph them. We've created ordered pairs that we can translate to the graph. So whatever we get here, that's going to be the graph for that equation. -5, 1, 2, 3, 4, 5, -1. -4, 0, 1, 2, 3, 4. -2, 2. -2, positive 2. 0, 4. 0 means don't go left or right at all. 1, 2, 3, 4. And what you've created is these points that I can connect, and it forms a continuous graph. Let's look at number 3 real quick. We'll skip number 2. We'll come back to it. If I look at number 3, y equals 3x. So here's my input numbers. I'm going to put each one of these in for x one at a time and get out new output numbers. If I plug a -2 in here, 3x means 3 times x, so 3 times -2 is -6. 3, putting a -1 in, 3 times -1 is -3. 3 times 0 is 0, and 3 times 1 is 3. -2, 1, 2, 3, 4, 5, 1, 2, 3, -6. -1, -3. 0, 0, that's the origin. 1, 1, 2, 1, 3, right there. So I've created some points that I can graph, and it will form a straight line. Number two. Number two has a fraction in it. Don't let that scare you, please. We're going to show you some, remember we're always learning tricks on how to deal with fractions. If you are plugging x numbers in to something that's being multiplied by a fraction, and remember, you get to pick these numbers. These, I know they're picked for you here, but if you're doing your own problem, you can pick whatever input numbers you want. If it's being multiplied times a fraction, always choose a number here to substitute in that is a multiple of 4. See, these numbers were picked because they were all multiples of 4. When you do that, remember, this is going to end up simplifying down to a whole number. So when I plug a negative 4 in, I get y equals 3 over 4 times negative 4 minus 2. When you multiply this, 3 times negative 4 is negative 12 over 4. Negative 12 over 4 is negative 3. So this becomes y equals negative 3 minus 2, and negative 3 minus 2 is negative 5. When you plug a 0 in, 3/4 times 0, anything times 0 is 0, this becomes just 0, and 0 minus 2 is negative 2. When you plug a 4 in, same thing. You're going to do 3/4 times 4 over 1, which would give you, if you do the math, it's going to give you positive 3. 3 minus 2 is 1. If you plug an 8 in, 3/4 times 8 over 1 is going to give you 6 eventually. 6 minus 2 is 4. So now we've got points we can plot. 1, 2, 3, 4. 1, 2, 3, 4, 5. Negative 4, negative 5. 0, negative 2. 1, 2, 3, 4, 1. And then 8, 4 is way out here off the graph, so I'm not going to worry about that one because I've got enough points here to graph. Okay, plugging numbers in. All right. Question 7. Here's your rule, y equals x minus 5, and here's your domain, meaning that for these problems, they want you to use these numbers to find the output numbers. Now, all we're doing here, we're not graphing this. Given each function and domain, find the range value. So we're just looking for the range. If these are domain numbers, remember domain numbers are your x numbers. So you're going to plug these in one at a time. So if you plug a 4 in here, 4 minus 5 is negative 1. You plug a 6 in here, for x, 6 minus 5 is positive 1. You plug an 8 in here, 8 minus 5 is 3. So the range is negative 1, 1, and 3. So the same thing with all these problems. Okay? So you're going to plug in these numbers. This is domain numbers, so you're going to plug these 4 numbers in for x one at a time. Sorry, this problem here. So plug a negative 1 in, see what you get out. Start over. Plug a 0 in for x, see what you get out. Start over. Plug a 1 in, see what you get out. Start over. Plug a 4 in. Okay? And then all you're looking for in these problems are just the range values. All right. So just a quick refresher here. This is the way that you can represent relations as ordered pairs. We talked about that over and over. Tables, mapping diagrams, equations, and graphs. Okay, these are the different ways that you can represent relations. I would probably print this paper off and keep it in your notes so you have it. Okay, that is assignment 14.